Welcome to our presentation on the transition to integrated practice and design education. I'm Phil Bernstein, Vice President of Industry Strategy and Relations at Autodesk, and a lecturer in professional practice at the School of Architecture at Yale University. Integrated practice is a large issue being discussed by architects today in the United States, and educators are asking themselves how we might prepare architects in the future for this new trend. One of the topics that many architects in the U.S. are discussing today is this idea of integrated practice, changing the relationships between the activities of design, construction, and facilities management. And at the center of that discussion is this idea of building information modeling. Building information modeling is a strategy, a tool, using technology to represent buildings as digital simulations rather than using technologies to make traditional CAD drafting drawings. And that idea really addresses this concept of integrated practice in a fundamental way. It's a platform that can be used for having our students understand the life cycle of buildings, the relationship between the players in the project, methodologies for collaboration, and really giving them the ability to create profound design information as part of the design process. And the question for those of us who are educators is really the following. How do we integrate these ideas of integrated practice, building information modeling, and building lifecycle management into our curricula so we can prepare our students for practice in the future? And that practice will include some fairly significant trends. It will include ideas of designing in 3 dimensions. It will include ideas of how to teach tectonics, the relationship of building pieces using technology. What we really need is a platform that we can use to express and understand these kinds of ideas and really train our students for the integrated practice models of the future. And really there are a number of larger trends here that we're trying to get the future architects of tomorrow ready for. All of them are related to this idea of integrated practice, which will change the roles and relationships of the players. But those ideas include trends like sustainable design. Sustainable design is clearly something that our students will need to be prepared to execute on for years and years into the future. Sustainable design is an activity that is predicated almost exclusively on the concept of being able to simulate a building and predict the outcomes of the design before the building is built. A building information modeling platform in the context of an integrated design curriculum is a perfect technique or methodology for creating that kind of a pedagogical context. Secondly, our students are tremendously interested in the ideas of design to fabrication. What is the physical manifestation, the physical ramification of the design idea that they're trying to model? And a building information modeler is a great platform for trying to create that kind of a context and use that information not just to visualize the design phenomenon, but understand how it's going to be made. And also many of our students are interested formally these days in much more complex geometric forms that have immediate tectonic ramifications, and having an environment in which you can understand the construction ramifications of these very complicated forms, parametric forms that designers are interested in today, is an appropriate approach to integrating technology and certain pedagogical ideas into the studio. And so what we'd like to suggest to you is that building information modeling is a catalyst by which you can begin to introduce ideas of integrated practice into the studios in schools of architecture and into the classroom. And to take that idea further, to discuss it in a little more detail, I'd like to introduce my friend and colleague, Harrison Fraker, the Dean of the School of Architecture at the University of California, Berkeley.
Thanks, Phil. We've been talking for quite a while about what are some of the best strategies for integrating BIM into the curriculum in schools of architecture. And Autodesk helped us just this last summer by sponsoring a special experimental studio on BIM, which we taught here at the College of Environmental Design. We found that, first of all, that the students at all levels could really master BIM in that fairly short 10-week period. In architectural education right now, students are really interested tremendously in the art of building, in how buildings actually go together, and not just in terms of what's the most cost-effective construction and what details are going to perform the best, but how the actual way in which the building is made can be part of the artistic statement of the building. And this means that the kinds of information that they can get from using the full potential of Revit is extremely valuable to them now. So it's a very opportune moment in architectural education. Students are also interested in process. They're rediscovering that process has a huge impact on the actual artistic expression of building. And that means process from the very beginning, process from conception to construction and to the ongoing performance of building. At the very same time, we have this amazing step change in consciousness about sustainability, created primarily by all the issues and concerns around global warming. But suddenly, the performance of buildings, how they use energy, how they interact with their climate and environment is absolutely critical to the ethical and moral values of the next generation of students. They're the ones who are going to have to really solve the sustainability and energy problems that we face on this planet. And this made me realize when we started to think about how to integrate Revit into the curriculum that Revit could be a fantastic teaching tool for teaching the fundamentals of architecture as well as the fundamentals of assembly and construction, something that we call in the field tectonics. And that this would be a way for the students to learn Revit without thinking of it as a technology, as a sort of drafting tool, but as a way of thinking. And this is a critical thing that needs to be done. They have to see it as a part of their own imagination, and we have to come up with a pedagogy that allows that to happen.
My name is Dan Sullivan. I'm a fourth-year undergraduate at UC Berkeley, major architecture. Before coming to Berkeley, my experience with computer design really just involved using AutoCAD for purposes of drawing details or plans and sections. But in the process of encountering computational aspects of design, I began to explore the potential of using algorithms in architecture. I think that building information modeling will provide a link between the blobular forms that we see coming out of programs like Maya and grounding them in the potential of actually being constructed. In this day and age where computational design is really the wave of the future, it is imperative to attend a program that provides for all these changing technologies. I think that the availability of three-dimensional software, of CAD software, of the techniques necessary to learn these programs and to develop scripting techniques for these programs is really going to be essential in the future of architecture.
What I found so interesting about this computing revolution is that in some ways the advances seem to jump back and forth between the professional environment and the environmental of the schools. And certainly in terms of the early adaption and use of BIM, it's my understanding that certainly the profession has led the way here. But very quickly, I think the schools will integrate BIM into their curriculum, and very quickly they'll start to experiment with it. And in some ways, they might start creating some of the leading edge transformations of BIM. But there's no question in my mind that BIM is the direction that the whole design professional community is going. And the schools need to recognize this, integrate BIM into their curriculum, not only use it as a fundamental tool, but also begin to experiment with it and begin to point to some of the new directions that BIM might take. It really is the future for both education and practice.